Welcome back. In this video, we're going to talk about how to solve for x when what you're seeing is not an equation but an inequality. Okay, so first of all, let's talk about what exactly is an inequality. Okay, my handwriting is bad, so I'm just going to convert this to text. There you go. So what exactly is an inequality? So an inequality is any expression that kind of shows if a number is if two quantities are not the same. So if I have quantity A and then a quantity B, then A can, so if it's an equality, then A is equal to B. So that's the equal to sign, which says that A is equal to B. Okay, or what's on the left hand side of the equal to sign is equal to the right hand side. Now, if it's an inequality, then either A is greater than B or A is less than B, okay? So in mathematics, essentially, we replace the greater than with a sign that looks like this. And we replace the less than with a sign that looks like this. So if I had to say A is greater than B, I can simply say A greater than B with that sign. That's what the sign means. Then I can say, if I say A is less than B, I can say A less than B. There you go. Now, in addition to that, sometimes, depending upon the problem that's given to you, something on the left may be greater than or equal to, right? So if something, so let's say I have A is greater than or equal to B, then what we do is we represent it as, we put the greater than sign and then we take one of the little lines from the equal to. So see how the equal to has two lines? We take one of the lines and we put it underneath the greater than sign and then we put the B on the right. So this means that A is greater than or equal to B. Likewise, if A is less than or equal to B, we write it as A, we put the less than sign, and then we put the half line of the equal to beneath the less than sign and put the B out there. So this is what you need to be familiar with, okay, these signs and expressions. So let's take a look at an application of this in the form of some problems. Okay, again, pause the video at any point in time, take down your notes, try to solve the problem, and then, you can continue from there, unpause and kind of take a look at how the solution works out. Okay, so let's say you're given a problem, and let's say that this is your instruction. Solve each inequality and write the solution set. Okay, let's go ahead and change this into text so you don't have to deal with my handwriting. Okay, so first problem. Okay, so let's say I give you x plus 6 is greater than or equal to 3. Okay, so to solve this problem, you want to approach it exactly the way you would approach any linear equation in x, solving for x. So the first job is we need to get rid of the 6 from the left hand side so we can isolate the x. So we're just going to subtract 6 from both sides. And when we do that, the 6's go away. So that leaves us with x on the left hand side. And then the right hand side becomes negative 3. All right, so that's the end of the solution of this problem. But then what does this mean? So this means that if you had a number line, so let's draw a number line out here. And the number line ranges from negative infinity to positive infinity. And let's say you have 0 right in the center. So negative 3 would be, let's say negative 3 is somewhere out there to the left of 0. So what this means is that the value of x can be any number greater than negative 3, but x could also be equal to negative 3. So what we can say is that x can be equal to -3 and then any value greater than -3 right up to positive infinity. Okay, so now the way you represent this is because 3 is included, okay, when 3 is included because of the equal to sign, you put a little square bracket on the 3, okay? I'm going to use a different color for the square bracket. So you put a little square bracket on the 3, and the square bracket will open out in the direction of the possible values of x, okay? So when you, so that's how what we wrote out here is, this is if you had to graph the solution on the number line, that's what it would look like. But then the question is saying write the solution set. So the solution set is actually going to be, you start out with a square bracket, the same square bracket that we put out there. You put the -3, and that, remember, this square bracket means it includes the value of -3, okay? You put the -3, and then you put a comma, and then you put the infinity. So it's, what you're doing is you're starting off with the least, the range. So the -3 is the least possible value of x, and then infinity is the greatest possible value of x. So there we go. And then you put a, close it with a regular parentheses. Okay, so that's the solution set. All right. Okay, let's take a look at another problem. Same instructions. So let's say you're given -3x is greater than -33. All right. So at this point in time, now to isolate x, we have to divide both sides by -3. Okay. So here a new rule emerges. When you're dealing with inequalities, when you divide by a negative number, the sign, or let's put it this way, the inequality flips. What that means is this one changes to this one, or if you had to begin with the less than sign, that would change to the greater than sign. Okay, so coming back to the problem, x is less than, note carefully, there was a greater than sign, now it becomes less than, and then when you divide -33 by -3, you get 11. All right. Okay, on the number line, what does this look like? So let me go ahead and draw a straight number line. Okay, positive infinity, negative infinity. Let's say we have 11 out there. So what we're saying is that x can have any value less than 11, but not equal to 11. So we start with 11 and we shade all the values from 11 to negative infinity. But then because 11 is not included, we use a regular bracket, but we again, the bracket, it opens out towards all the possible values of x. Okay, so that would be the graph, and then the solution set would be open bracket, negative infinity, comma, 11, close bracket. All right. Okay, let's try another one. Let's say you're given -6x less than or equal to -18. Similar logic, we're going to divide by -6, right? So let's divide by -6. And then that would flip this sign to greater than or equal to 3. Okay, so on the number line, well, let's put the 3 out here. It's a positive number. So so what we have is x is any value greater than or equal to 3. So it's going to be shaded there. Now, since it's greater than or equal to, we're going to put the little square bracket this way. And so the solution set is going to look like this: 3, comma, infinity, close bracket. Okay, or close parentheses. All right, next one. Zoom up. Okay, let's say you're given this one, 8 times k minus 5 minus 2 plus 7k greater than or equal to 4. All right, so the first thing you need to do is just go about solving this like a regular equation. So 8 times k times 8 times my negative 5. So you go ahead and distribute the 8 with the k and the negative 5. Distribute the negative sign out here, so you can put a little 1 out here to make it easy with the 2 and the positive 7. Okay, so that gives us 8k minus 40, negative 2, negative 7k greater than or equal to 4. Let's combine like terms now. So 8k and 7k make k, and negative 40 and 2 makes negative 42. All right, now let's push the 42 over to the right-hand side by adding 42 to both sides. So I get k is greater than or equal to 46. All right, so as you can see, if I put the number line out here, make a straight line. Let's say I have 46 out here. That's 0, infinity, negative infinity. K is any value greater than or equal to 46. So I put a square, I put a square bracket there. And so the solution set is 46, comma, infinity, close bracket, or close parentheses. All right. Okay, let's do another one. Again, pause the video at any point in time if you feel I'm going too fast through this. And make sure you can solve these problems as you work through them, okay? Okay, there's no rush. Remember that, there's no rush. Negative 3 less than or equal to 2x plus 1 less than 4. Okay, so now this is an interesting one because you don't have one inequality, you have two in the same expression. So what you want to do is, to solve it, look at where the x is. See, the x is in the center. So try to figure out how to eliminate everything else but the x from the center. So start with the positive 1. So offset the positive 1 by adding negative 1 to all sides. Watch, I added negative 1 out here, but I added negative 1 on this side of the inequality and on this side as well. Okay, since there's two inequalities, you want to do the same thing all over. So what that gives me is negative 4 less than or equal to 2x less than 3. Okay, now I'm going to divide everything by 2. So that gives me negative 2 less than or equal to x less than 3 over 2. All right, so that pretty much is where you stop, okay, for this one. So now let's take a look at on a number line what this starts to look like. Okay, so we have the negative 2. So let's put the 0 out here. Let's say you have negative 2 out here, and then let's say you have 3 over 2 out here. All right, so basically what we're saying is that x, so you have negative 2, which is less than or equal to x, right? What that means is that x is actually greater than or equal to negative 2, okay? So x would start with all the values going this way, and it's greater than or equal to, so there's a square bracket there. But then x, it says that x is less than 3 over 2. So you can only go up to 3 over 2 for your values of x, and then you're going to close that because you're not including the 3 over 2, okay? So that leaves you with a solution set of negative 2, comma, 3 over 2, close, okay? All right, let's do one more and then stop. Okay, so the next problem is going to be negative 10 less than 3x minus 4 less than or equal to 14. All right, so let's go ahead and get rid of the negative 4 from the middle out here. So add 4 to both sides. It gives me negative 6 on the left, less than 3x, less than or equal to 18. All right, then I divide everything by 3 to isolate the x. So that gives me x less than -2 less than or equal to 6. All right, now let's see what this looks like on our number line. So there's the 0, there's the positive infinity, there's the negative infinity. You have -2 out here. Let's say you have the 6 out here. All right, so what we're saying is that x is actually greater than -2. Or if you want to read it from left to right, -2 is less than x. So whenever you read from left to right, -2 is less than x. But if you're reading this from right to left, then x is greater than -2. So what that means is that starting with -2, you're going to keep going till you reach 6, right? But x is less than or equal to 6. So you go there and you stop at 6. So now we put a square bracket on 6 because of the equal to sign. But then we put a little regular parentheses on 2. And the solution set for this is going to be -2, comma, 6, square bracket. And that's pretty much it, okay? So this kind of review should have kind of, given you a flavor of pretty much the types of inequalities that you need to know for this stage, okay? Thank you for watching. I will talk to you guys in the next video. Bye.